Hello guys, in this video I'll be solving the last question from today's weekly contest, and you can see the question: apply operations to maximize score. You are given an array nums of n positive integers and you are also given k. Initially you start with a score of 1, okay, and you have to maximize your score, okay, and you can apply some operation k times, at most k times. So what would be the operation? So you can see, choose any non-empty subarray from L to R in between the array, and that should be unique. So you cannot choose the same subarray again and again. Just you can choose once and choose an element X of that subarray which has highest prime score. Choose the one with a smallest index. Okay, in cases when multiple elements exist having that same highest score, like if two elements having prime score of 2 and 2, like that is maximum, then you have to choose the first one, like left from left side, okay. And after choosing that element, if that element is X, multiply your score with X. So the prime score, okay, so since we were comparing all the elements in the subarray using prime score, so let us see what would be prime score. Prime score will be, for any number, just create a product, create the product of distinct prime numbers, something like this, and just check how many distinct prime numbers are there. 2, 3 and 5. There are 3 distinct prime numbers which create 300. So 3 will be the prime score of 300. Okay, so here what you have to do is, you are given array. From array you have to find all the subarrays. Like trivially what you can do is, you can find all the subarrays, and from all the subarrays you can find out all the like for every subarray you have to find out the number which has maximum primer score, and if multiple such numbers, the first number having maximum primer score, and you have to find out, like, and you have to multiply all of them k times. So you have to choose the set of those subarrays uh, like in different ways, and you have to find out in which case the score is coming out as maximum, right? So trivially, like if you are going to choose all the subarrays, and then you have to find out uh, the set of subarrays which will have maximum a score. So obviously choose we will try to do the operation as much as time possible. So at most k times. If it is possible to do operations k times, then we will do operations k times. Try all the subarrays, or we will try the subarrays which gives maximum, which adds maximum score, okay. And let us see the constants as well. So here the number of elements can be up to 10 to the power 5. And all the values can also be up to 10 to the power 5. And k means the number of operations that will be, like the subarrays that you can choose, the distinct subarrays to do the operation. So that would be up to 10 to the power 9. Finally, the answer can be very large, so you have to return it by modulo of 10 to the power 9 plus 7 with an example given as 2. Okay, or not 2, let's make it a bit more. So let's make it 3. Okay. Now, how much how much can be the maximum score? Like that would be possible with this. So yeah, the first thing what I have done is I have found out primer score for all the numbers. So I think you have understood how to find primer scores. For 19, you will just have 19. So there is no prime factor of 19 other than 19, so it's just 1. For 12, you have prime factor as 2 and 3, so there are 2 prime factors, so 2 is the prime score. For 14, it's 2 because 2 and 7 are 2 prime factors. 6, you have 2 and 3. For 10, you have 5 and 2, and 18, you have 2 and 3. So again, yeah, initially your score is 1. So now let's choose some sub-arrays. So what I'll choose is, first thing is just choose. So you have to make sure. Okay, so this is the sub-array. Then here you have to find out any number which have maximum prime score. So the prime score, maximum prime score is for 12 and 14, but we have to choose 12 because it is having lesser index. So you can just multiply with 12 and then you can choose something another. But yeah, do you think that if we choose 12, then it will be resulting into something uh, higher a score, higher answer? Because we need some like higher score, right? So to have higher score, you have to choose something maximum, some value which has like more value. If you look in this array, so 19 is the value which 19 is the number which has maximum value. So for this, to choose 19, what we can do is we can choose this subarray. So we will use some greedy approach to find out elements which has maximum value, like of if we choose 19, then the score will be 1 into 19, right? So on every possible subarray that you choose, there like you have to make sure that you are finding something, you are finding x, like you are finding the element which you will going to multiply, that has to be maximum, right? So if you choose this subarray, then just 19 as a subarray, then there is, it's not empty as well. But yeah, here the number which is having maximum primer score is also 19, so you can choose 19. But you, if you choose 12 or 14, anything after 19, then 19 will not be the number again to be chosen here, because the maximum primer score will be for 12 or 14 or something. But yeah, it will be for 12 sure, for sure, because it is having lesser index. So if you choose, for example, if you choose 1912, then 12 will be uh, the number which is having maximum primer score and lesser index. Even if you choose this, then also 12 will be uh, multiplied. Even if you choose this, then 12 will be multiplied. Then if you, even if you choose, then 12 will be multiplied. Why? Because all of these are having same primer score, but 12 is having minimum index as at least. That's why 12 is chosen. So since 19 is chosen and 19 had maximum value, and we cannot find out more subarrays where 19 can be multiplied, so we will look for any other number which can be multiplied at some maximum more value, some higher value, and we can find out all the possible subarrays with that. So after 19, let's look at other number. So that is 18. I think 18 is the second maximum number here. If we choose 18, then let's find out subarrays that can be possible with 18. So if we choose 10 and 18, I don't think 18 will be chosen here to be multiplied. Why? Because 10 is have both are having same prime score, but 10 is having lesser index. That's why 10 will be chosen. So this cannot be chosen as a subarray where 18 can be chosen to be multiplied. So just this can be a subarray where 18 can be multiplied. So for 18, like it can be multiplied once only. I don't think other than this we can find out any other subarray with 18. So yeah, this will be the next a score, like just we will multiply with 18. So how many operations we have done as of now? So we have done 2 operations. So now we will choose any other subarray and we can see like what we can multiply as maximum value other than this. So 18 we have chosen. There is nothing left for 18. Like there is no other subarray left which can uh, help us to multiply 18. So let's choose something other. So let's choose 14 after this. So let's find out subarrays which can be generating for which can help us to multiply 14. We choose 14, something like this. What do you think? Which number can be multiplied in this case? It will be 14. Why? Because all are having same prime score, but 14 is having minimum index. So we can just multiply 14 here. And now all 3 operations are done. So here this will be giving out the result. So let's not calculate that. But yeah. And we can also find out the number of subarrays that are possible for 14, the number of subarrays which are possible for 19, which are possible for 18. So this is how we will approach. So we will, with a greedy approach, we will start with a maximum number, maximum value, and we will proceed toward lower value. And for every value, we will try to see how many operations we can do, or like we can also say that how many subarrays like we can create with after choosing a certain number which can be multiplied. So if 19 has to be multiplied, how many subarrays we can create with 19? How many unique subarrays we can create with 19 where 19 can be multiplied? If 12 has to be multiplied, let's suppose if 12 has to be multiplied, then how many subarrays we can create where 12 can be multiplied with the score, right? So if 14 has to be multiplied, how many subarrays for if 14 has to be multiplied? So that thing we have to find out. So again, for that thing we have if we have to find out that thing, we have to look at some boundaries. So let's see how we will look for boundaries and how we will be finding out the count of possible subarrays if that number, if a particular number has to be multiplied. So now we'll be looking at that. Friends, I have just written prime score for all the numbers. So we do not know the number here. We have already calculated prime score. And for every number, we are trying to find out the count of possible subarrays where we can multiply that particular number. If for 2, like for 2, there should be some corresponding number that we are not looking at now. And that number, how many times we can multiply, considering that 2 is the prime score for that, and all the prime score circle are found out already, right? So for the number at index, at first index, like 0 index, we how many subarrays we can create. So you can see that for 2 we can just create one subarrays. Why? Because if we choose 2, then we cannot choose 5. If we, because after choosing 5, we have to like multiply the element corresponding to this. Why? It has more prime score. If we choose 4 after 2, then like if we choose 2, 5, 4, then again we have to choose 5. Not, we cannot choose 2, right? So To choose 2, we have to ignore any other number which has more prime score. So any number which is having more prime score, I'll just avoid. So for 2, we can just have one subarray. So after having more prime score, we will just stop, right? Okay, let's now look at 5. So for first index 1, we are looking first to the left, and to the left, if we take a look, 2 is lesser than 5. So we can choose this. Even if we choose this, we can multiply the number corresponding to this, right? Now look at right. Even if we choose 4, the number with prime score 4, then also we can choose the number corresponding to this, right? So we have to choose all the numbers which has lesser prime scores. Yeah, and we have obviously we have to make sure that we are looking into nearby only. We cannot jump out there and here and there, right? We can look subsequent continuously, like one after another. So if we found any number which is having more prime score, then we will stop. So here after 5, we have 6 as like higher prime score. So we will not go to 6 till 6. We will just stop at 3. So till 3, we can keep it in the subarray to make this element, the element at this, as like a multiplication to the score. So that we can multiply. So for 5, how many subarrays we can have? Till here, like there are two possibilities. Either we can just choose till 5, or we can choose up to 2. So there are two possibility here, and there are, if you can apply here, apply combinatorics here. So here a kind of combinatorics can be applied. So we will just look at the left side. So how many, and we can see how many elements we can have in the left. Okay, and then also we can see how many elements we can have in the right. Okay, so we will just look at left and right, and we will see how many subarrays we can create. So here we can, here the number of subarrays for 5 will be 2 into 5. So there are 10 subarrays, there are 10 possible subarrays. Just 2 into just left count into right count. So that will be all the possible subarrays where 5, the element with 5 prime score can be multiplied. Now look at 4. With 4, if you look at left side, so after 4, 5 is coming. So I think I have done some mistake here. So if we are looking at 4, the possible subarrays will either contain 4 or either contain 4, 3, right? Because in the left we cannot go, we cannot include 5. If we include 5, then 4 will not be multiplied, because it will no longer have maximum prime score. So for this, we will just have two possibilities. Now you can like you might have the idea that in the left you can just multiply 1, because we are not going further. So, and for the right you can just multiply 2. So 1 into 2. So there are two possibilities, either just 4 or 4, 3. Okay. And again, if you come at 3, so in the left, how many maximum elements you can choose? After 3, 4 you cannot choose. Why? Because 4 you will not have, 3 will not be the, no longer be maximum prime score. So we can just have 3 as one subarray where it will have maximum prime score, and the number corresponding to this can be multiplied in the score. With 5, we can include all the way till 3 and 4, but we cannot include 5. Why? You can see why we cannot include 5, because if we include 5, then this number will be multiplied. The number corresponding to this will be multiplied. Why? It is having lesser index. So if we are looking to left, then we will just stop when it encounters the same value, the same primer score, right? And if we look into the right, we can proceed even after getting the same primer score. We can proceed till getting till getting more primer score, like higher primer score. So if we are looking into left, we will just stop after encountering same value. So at this we are stopping, okay, and in the right we are stopping like after getting more value, that is 6. So here how many subarrays are possible? So here 3, like into left, if we are looking, then like all the possibilities, the possibilities of lengths in the left we are 3. So we can just include 5 or 5 3 or 5 3 4. So there are 3 possibilities. In the right we have we can either just have 5 or we can have 5 3. So there are 2 possibilities. So 3 into 6, 3 into 2, 3 into 2, that means 6 subarrays are possible where the number corresponding to this 5 prime score can be multiplied. Okay, and if we include these 3, then how many subarrays are possible where the number corresponding to it can be multiplied? So here it's just 1, because here if you look into the left, you are encountering higher value, and if you are looking to right, you are just encountering higher value. So there, in the left you have just have one possibility, the length of 1 only, or in the right also you have just one possibility. So 1 into 1, 1 subarray possible. For 6, how many possibilities are there? So for 6 we will find out. So for 6, in the left we can look into all the numbers. I think all the numbers are greater, so we can either choose 6 or 6 3 or 6 3 5 or 6 3 5 3. Like all the numbers are possibilities for it. So we can just have 1 2 3 4 5 6 7 possibilities in the left side. And how many possibilities in the right side? 2 possibilities, either just 6 or 6 1. So there are 2 possibilities here. So 2 into 7, that means 14 subarrays are possible for 6. Now looking at 1. So for 1, if you look into right, at the right, you come to the end. So no possibility in the right, and in the left also you are having a value which is higher, so that is 6. So you can just have one subarray for this last number which is having prime score is 1. So this way, for every number you will be finding out the count of all possible distinct subarrays that where that particular number can be multiplied into a score. Okay, so this we will be finding out. So for all the numbers we will be finding out this. After finding out, will we grid, then again we will do greedy, that we have already discussed. So after so prime score will just help us to create, prime score will help us to find out the count of subarrays, the count of the possibilities of all the subarrays where operations can be applied for any number. So if we do this same thing over here, so I'll just be counting possible subarrays here. Guys, here I have found out all the possible subarrays for all the numbers for these numbers, right? So here you can find out that if we have to include 19, there's just one possible subarray. So we can just include it in one operation. So 19 can be included in just one operation. 18 can also be here also we can just have one operation, that will be maximum, because this is the all the possibilities. And for 14, this is the third thing. So for 14 you can have 4 possible subarrays where you can like multiply 14 only. But yeah, since the maximum possible operations is 3 that is given, so you should not exceed 3. So we will just include 14 once only. In case if k would have been given 7, in case if k would have been given 7, let's suppose, then we would have multiplied 14 more times. So how many times we could have multiplied? So we have just we are already exhausted 2 times. So 1 for 19, one is 18. So we will be having 5 remaining. So for if 5 remaining, then we will just use 14 to the 4 times. All 4 times we will just include it, right? So again, even after this, we will be left with one operation. So already we have done one operation here, one operation here, 4 operations here. That means we have already done 6 operations, one operation remaining. After 14, we can choose next element gridly. So we have already chosen these two, so we will choose 12. And for 12, how many subarrays can be possible where it can be included? So there are 10. So yeah, we are left with 12 as well. So let's multiply 12. So in case if 7 would have been given as k, then this should be the answer. If k is 3, then yeah, we will not do this operation, like we will not include 12, and we will also do just once. So this is how we will find out the score. So this is a greedy way, but yeah, before applying greedy, you have to find out possible subarrays. To find possible subarrays, we have to find boundaries, like in the left and in the right. So to find boundaries, I'll use a stack. So in the stack, like I have uh, let's see the implementation now. So there we will see anything left here to demonstrate. I think we are now able to find out the score. So yeah, this should be okay. So let's go to the implementation part. You can see like there's so many multiple things to do here. So I'll just start with the first thing, that is to find out prime score. So what I've done is I have found prime score. So to find prime score, what I have done is, since you have to maintain time complexity of order of n log n, so and also like the numbers are given 10 to the 5, this thing, at least this thing. So to find prime score will be a challenge, like if you have to do it in lesser time complexity, because you cannot apply all this. Uh, if we do if we find out prime score by just dividing and dividing and trying all the possible prime numbers, then like it will have time complexity of 10 to the 5 into 10 to the 5. Why? Let's see. 10 to the 5 will be this number, and 10 to the 5 will be, if number is 10 to the 5, then 10 to the 5 times can be the way to find out all the prime scores, like to count the prime score finally. So for that, we have tried to memorize things, right? If we have already found out that prime score for n, then we will not find it again. So in that case, we will just return that only. We are initializing with 0 because prime score will never be less than 1. So yeah, initializing with 0, that will help. And then since the range is up to 10 to the 5, so primes will not be a lot. So let's see how we are finding out. So why we are doing it in till just 56? So it's not 56. Like let's copy some another code from here. Okay. So you can see possible primes are just these many. That's why 56 has been written. So we will not exceed at least 350. So all the primes are within the range of 350. So not 350, it's, you can say, a square root of 10 to the power 5, and that is around 334, right? So all are within 334 only, and that's why, and this count is 65. Okay, that's why 65 is done. And you are looking at all the primes, and before that I have also find out all the primes. So to find the primes, what I've done is, I think you guys know this, or if you don't know, like you can check check out in the Google, you can find out this algorithm to like just you can start with 2 and then you can go to till a square root of this, that will be 334, and there you can check if it is already prime or not, and if it is prime then you can include in the primes. Other than that, you can make other numbers non-prime, like which are divisible by this. Same thing you can do. So let's suppose you have found out the primes. I'll just link the solution in the comment section so you can look into the more illustrated solution. So I'll update the solution accordingly. Okay, so here to find out prime score of n, what you have done is this is memoization thing that is done. Then you are checking with all the primes. If that is divisible, then you are including, you are increasing the score. Otherwise, you are decreasing in value. Okay, at the same time, you are decreasing in value as well to reduce the computation. Right? You are also checking this to reduce the computation. And finally, you are finding out prime score. Okay, this is the first thing. So you are now you have now calculated prime score for all the numbers, and using this prime score, remember what we will do? We will find out boundaries and all the possible subarrays subsequently. So to find out possible subarrays, we will find out boundaries. To find out the boundaries, what we have done is we have initialized a stack, and the stack, what we will do is we will just pop out every element which is lesser than my current element. So after popping out those elements, like while popping out also, we have to see if that element is smaller and it is lesser than this, then I should be the right element. I should be the first right element to this jth element. Like if on the stack we will have jth element, and for that jth element we are larger, right? We are having higher prime score. So ith is having ith element is having higher prime score. So ith element will be its right right boundary. So I will be right boundary for j, where it's have where it is encountering higher prime score. So I minus j will be the possibilities in the right side, so that is multiplied in the possible subarrays. So I minus j is possibilities in the right side for j, so it's included in j. Just remember it, it's included in j. Why? Because j is lesser than I, right? And I is like till before I only we have to include for jth element. Okay, let's look for ith. Okay, once popping out all the elements from a stack which are having lesser value, what we will encounter? We will encounter some value which is having more value or equal value than our own prime score. So once encountering that, we will stop and we will check the index of that uh, leftover uh, element on the stack. So the element which is on the top of the stack, that is remaining, which will obviously be larger or equal to this, because we are anyway popping, so remaining will be just equal or greater. And if that is there, then we will do this, or if not there, then we will just do I plus 1. Why? Because if there is stack, then our left boundary for I is 0, and that means from 0th element you can count all the like if we are having 2, 2, 3. So for 3 we will have 0 as the left boundary, so we will just include all the values. So I plus 1, so here I will be 0, 1, 2, so I will be 2, I will be index, right? So index will be 2 here. So 2 plus 1, 3 will be the possibilities in case it's not there. If it is there, so in case if it this is a 4 only, so we will stop at here, and it and the value will be I minus the previous greater value, previous big value. Okay. And this is multiplied. These are the possibilities in the left. Remember this, we have multiplied the possibility in the right, and here we are multiplying possibility in the left. So after multiplying both of these, we'll find out all the possible subarrays. Like, and again, after doing operations, after finding out possibilities for n, so every time we are finding possibilities for left side, as we have already encountered these in a stack, but for right side we will have some leftover. So all those elements which are still left in a stack, that is previous bigger values. So any previous bigger values that is not have, that have not encountered any a smaller value, like in this loop only. So we will just make the next bigger value as n, because since it has not encoded any, so it will just last index. So n minus j will be like possibilities in the right for all these j. So all these j, we have some possibilities, but for this also we have some possibilities, but yeah, this is the last index, till the last index. Okay, no barrier. So till n, here also no barrier till like -1, or like even till 0th index, that is +1. That's why. Okay, and after this, remember I have said something, to apply greedy. To apply greedy, we will sort the array possible. Okay, here few things to note down here. Like in the stack, we will have index by index, because uh, index will help us to count boundaries. Okay, so in the stack we will have index, and we will have primer score. Primer score will help us to compare, right? And in this possible subarrays, we will have number value. Possible subarrays, let's find out. Yeah, possible subarrays will have number value. Why? Because this we have to multiply, right? And another thing is, we will just have possibilities. So you can see we are multiplying all the possibilities in the left side, right side. Okay, doing the combinatorics here. Again, after finding out possible subarrays and all the numbers, like corresponding number that can be multiplied, we are sorting it to like have to calculate some greedy value. So after sorting, we will just sorting in the decreasing order. Why? To make uh, to start from the first element, and first element will have larger value, and we will just multiplying larger values and larger values. So here ps dot first is number only. Yeah, ps dot first is number here, and ps dot second is frequency, like the count of operations we can do to this number, or count of distinct server is possible for this number to be multiplied. Okay, so that thing we will do. And in last, if we will not have enough operations left, they will just do k operations, like just leftover operations. So here we are just increasing k only. So we are not like finding out, uh, we are not taking any new variable. We are just using k variable only, decreasing k value after doing the operations. Like, yeah, so the number of operations we do, that many number we reducing by from k. Okay, so finally, after doing all these k operations, like with multiplying with max, we are returning answer, and it does provide correct answer. Okay, thanks a lot, guys. I hope it helped. Obviously this was kind of difficult question. One more aspect I can cover is like to find out power. So to find out power also, if you'll do something trivial, it will also take much more time complexity, and it will also give time limit exceed. So to make this power thing also work in limited time, what we will do is we will apply something like a kind of bitwise operation. So if you are doing 3 to the power 5, then what you will do is you can write it as 3 to the power 2, and 3 to the power to the 2, then whole power of 3 to the power 2 to 2, and then into 3. Yeah. So here, this you can see how you can split any power. So if you will do, if you will multiply 3 to the power 5 times, then what you will do is you will have 5 operations. And if you break down the problem into a square and a squares, then you will have lesser operations. You are just having 3 operations, right? So it will just be a kind of bitwise operation. So if 5 is like 5 for 5 you are, so it's different thing. For 5 you are writing it as 2 into 2 plus 1. That's why what you are doing is you are first you are finding out power of like a square of 3, and they were squaring that a square of 3 to make 3 to the power 4, and they were multiplying with 3, and that has been done here recursively. So you can check it. So if I think this is going it is taking lots of time. I will explain this in my answer, so you can check it, or you can check it on the internet how to take power of certain value. You will find certain solutions that will be very optimal as it is given here. Okay, so thanks for watching, guys.